Hello and welcome to Math with Mrs. Becker. Today we are working on calculus and finishing up Chapter 1, Section 4. What is really going to help us when we are working with radicals is remembering the difference of squares and how that works. Like if I have a squared minus b squared, if you take the square root of a squared, you get a. If you take the square root of b squared, you get b. And what you would do to factor is go a plus b and a minus b. Well, you have to realize that this property goes both ways. If you go ahead and multiply these out, if you FOIL them and combine like terms, a plus b times a minus b, you will get a squared minus b squared. Okay, so taking this property, if you need to cancel a square root, you need to multiply by a conjugate. Remember, conjugate means that you leave the first term the same, leave the second term the same. The only thing that you change is the sign in the middle. So again, leave the first term, leave the second term, change the sign in the middle. So one will be negative, one will be positive. If these are conjugates, notice it's going to follow the same thing here. I have a and b and a and b. So the first terms are the same, the second terms are the same. One is a plus, one is a minus. That's exactly what we have here. So what we can do is take the first value and square it, minus take the second value, and in our case, it's a square root of x, and square it, okay? So let's go ahead and see why on earth I would need to know how to do this, okay? If I want to find the derivative using the three-step method, remember that is f of x plus h minus f of x all over h. If I'm starting off with the function that is the parent square root function, okay, just the square root of x. Step one, I have a square root instead of x, it's x plus h, minus the original function is the square root of x all over h. Okay, so we're good to there. But now when I try to find the derivative, that means the horizontal distance between the 2 points on a secant line has to approach 0. Well, I cannot put a 0 here. So what you do, if you have radicals on the top and you cannot put a 0 on the bottom, you multiply top and bottom by the conjugate of the numerator. And check this out, it gets kind of wild. It's super fun. X plus h plus the square root of x. So notice what happened. I kept the square root of x plus h the same. I kept the square root of x the same. The original was a minus, so I did a plus. What you multiply to the top, you also have to multiply to the bottom. Using our little rule, I can now take the first value, square root of x plus h squared, minus the second value, square root of x squared. And that is over h times the square root of x plus h plus the square root of x. Okay, so I just use this property right here. Now here, a square cancels a square root. So it's x plus h minus square cancels a square root, x over h times the square root of x plus h plus the square root of x. Now when I go to simplify, x and a negative x cancel. H cancels h. So what I end up with is 1 on the top because everything on the top canceled. Bottom, square root of x plus h plus the square root of x. You can leave it like this, okay? Yes, I know you have square roots on the bottom, but you're not done yet. This is just step 1. Step 2, you have to go ahead and calculate the derivative knowing that the horizontal distance is approaching 0. I can fill a 0 in now. X plus 0 plus the square root of x. Well, x plus 0 is x. So this is 1 over the square root of x plus the square root of x. These are like radicals because they have the same radicand, the same number underneath. So I can go ahead and add them. 1 square root of x plus 1 square root of x gives me 2 square root of x. Now, this is my final step. So this is where you want to rationalize the denominator. Multiply both top and bottom by the square root of x. I have the square root of x over 2x. That is the derivative. So again, to recap, I had started off with this problem, okay? So I went ahead, did the three-step method, but when I got to step 2, I had to put on the brakes because I could not put a 0 in for h. Because I had square roots, One way to go around this issue is to multiply top and bottom by the conjugate of your radical terms. From there, I was able to cross off that h on the bottom that was causing the problem, leaving me with this. It's okay to have the square roots on the bottom of this step because it's not the final step. This is just in a format where it's okay to put 0 in for h. Once I do that, then this is your final answer, so you have to rationalize the denominator. Okay, let's look at another one. Okay, so if we are computing the limit where x approaches 0, okay, I can go ahead and, looking at this, I cannot put a 0 in here, right? If I try to just go ahead and fill in that 0 like we have been doing, that doesn't work, okay? So what I have to do, I have to try and see if I can go ahead and cancel that x by multiplying top and bottom by the conjugate of the top. Okay, so again, we ran into a problem because this time we're doing a limit. I cannot put a 0 in. I notice there's a radical on the top. One way to bypass this little bugger on the bottom is to multiply by the conjugate. The conjugate means I keep the square root of x plus 4 the same, and I keep the 2 the same. This is a minus, so I have to use a plus. What you multiply on the top, you also have to multiply on the bottom. Now, using the rules, because I'm multiplying conjugates, I can take the first value, which is the square root of x plus 4, and square it. Minus, take the second value, which is a 2, and square it. Over, I have an x outside of x plus 4 plus 2. Okay, what happens here? This cancels this. It doesn't change what's underneath. So I have x plus 4 minus 2 squared is 4. So I notice right away on the top, positive 4, negative 4. So what I have left on the top is an x over x times x plus 4 plus 2. Well, notice again, x cancels x. So now I have 1 over the square root of x plus 4 plus 2. Again, it's okay to stop at this point because we're not done with the problem. So don't worry about trying to rationalize the denominator. We have it now to a point where I can go ahead and find the limit of this as x approaches 0. I can fill a 0 in for that. So 1 over the square root of 0 plus 4 plus 2. 1 over 0 plus 4 is 4. The square root of 4 is 2, and 2 plus 2 is 4. So your limit, meaning as you are approaching 0 from both the left and the right side of the original function, your y value would be getting closer and closer and closer to the value 0.25 or 1/4. Okay, so that's the main idea for the day. Now the next idea, this is kind of cool. Remember yesterday we said that you can have a limit as it approaches positive infinity or as it approaches negative infinity. What happens in those scenarios is that you have a horizontal asymptote. As you go all the way to the right or all the way to the left, your graph is getting really, really close to a value, but it won't ever actually touch it, okay? So it says to calculate the limit as x approaches infinity of 1 over x. So what we have to do to calculate it is go ahead and see what happens. So they want us to do a little table. They said, all right, well, let's say that x is 1, then x is 10, then x is 100, then x is 1,000, and we're going to go crazy and even go to 10,000, okay, to see what happens, because this is going to infinity. It just keeps getting larger and larger and larger. So if I take 1 over 1, well, 1 over 1 is 1. If I take 1 over 10, it is 0.1. If I take 1 over 100, it's 0.01. If I take 1 over 1,000, it's 0.001. If I take 1 over 10,000, it is 0.0001. So what they want you to see here is if I have the function 1 over x, as my x values are approaching infinity, meaning growing larger, the y value, what it's approaching, is getting closer and closer and closer to 0. So the limit of 1 over x, as x is approaching infinity, meaning going all the way to the right, your y values are approaching 0. 0 would be the horizontal asymptote. Your graph would never cross the x-axis. Okay, let's look at another one. If I'm doing the same thing, if I want to calculate the limits, you can't fill infinity into a number or into a variable, okay? Because infinity is not an actual value. So what you need to do is go ahead and try numbers and see how the y value changes or what number it's approaching. So I'm going to go 1, jump to 10, 100, 1,000. So it's 1 over, in parentheses, I am starting with 1 squared plus 1. Well, that ends up being 0.5. Now, if I go ahead and I insert a 0, so I have 1, 0. Okay, so if I have 10 squared plus 1, ooh, it's 0.0099. If I go ahead and I insert another 0, so it's 100, it's 0.000009 repeating. If I go ahead and I change the x to 1,000, it's 0.000001. So again, as you're looking, as your x values keep increasing, going to the right, going towards positive infinity, our y values are merging to 0. So the limit as x approaches positive infinity of 1 over x squared plus 1 is 0. So now at this point, you might be saying, hey, I get it. If it's going to infinity, it's going to be going to 0. Well, not always. So that's why we need to do one more example, okay, just to show you that it's not always going to be a 0 if it's approaching infinity. So again, if you are calculating a limit where you're going to infinity, you have to make a table because you can't plug infinity in for x. So you start off, I go 1, 10, 100, and then I would at least go to 1,000, okay, because you're picturing that you're going all the way to the right forever and ever and ever. So you want to make sure that you do go to a significant difference from where you start to where you end the table, okay? If I go ahead and do this, the top is 6 times, I'm putting in a 1 minus 1. Okay, notice I put parentheses, that's the top. Divided by 2, I put in a 1 plus 1. Okay, so again, you gotta be really careful when you're doing this in the calculator. What I have on the top is in parentheses. Where I fill in the values also in parentheses. Same thing with the bottom. The denominator is in parentheses as well as the one I'm plugging in. I end up with 1.6 repeating. So 1.667 I'll put. Okay. Now I need to go ahead and insert a 0. So all you do to insert is you go to directly where you want that value to be. I want it to insert a 0. And if you're using a calculator like this, you go second, the delete key, that's insert, and I can put in a 10. Now I have 2.8095. Okay, so now if I want to go to 100, insert a 0, go to the 10 on the denominator, insert a 0, and I have 2.9800995. Okay, now if I go to 1,000, up arrow, where I want the 0, I want to insert a 0 to make it 1,000. Go to where I want the 0, insert a 0. So now I replace the x's with 1,000. And I have 2.9980. Let's say you were like, I'm not 100% sure. You can always keep going to the right. I can go 10,000. So let's insert another 0, just to make sure. Let's say you're not 100% sure. There's no rule that says how many values you can put in your table. Okay, if I put in another 0, I have 2.9998. So as you look, hopefully you see as the x values are getting larger, meaning you're approaching that positive infinity, your y values are getting closer and closer and closer to 3. So the limit as x approaches positive infinity of 6x minus 1 over 2x plus 1, the limit equals 3. I hope you guys had a great day finishing up Chapter 1, Section 4. I'll talk to you soon.